Hi everyone, I'm Saltuk Burancilik and this is my microwave electronics term project, design of a microwave amplifier. Specifications are, it should be stable, the frequency band is between 1.5 and 2 GHz, the return losses should be low and the nominal gain should be over 10 dB. Circuit schematic on AWR is here, DC biasing is low beta dependent, there are decoupling capacitors, there are RF chokes and DC blocks to separate the AC and DC signal paths. There are matching networks and stabilization networks, and the transistor is a high linearity silicon BJT. S parameter simulation shows that it meets the requirements. The circuit layout is here. It's 2000 mils by 1000 mils. We printed this board and I mounted it. Additionally, to improve the performance, I soldered these two capacitors and I determined the location and the values of these by using tuning sticks. The back side of the board is completely a ground plate. S parameters and P1 dB measurements are done by a vector network analyzer. I put the S parameters on AWR here. As you can see, it has very low performance. It actually attenuates the signal after 1.75 GHz and it has very high return losses. We don't want any of these. However, I didn't have much time to improve the performance of the amplifier, therefore I decided to carry on with the measurements at 1.5 GHz, where it has quite enough gain. P1 dB measurement setup is here. The VNA's ports cannot handle high powers, therefore we have to do this setup. We first amplify the signal, then pass it through our amplifier, and then attenuate the signal. The gain of this setup is linear here, but then starts to drop off when the input is around 3 dBm, and the gain drops off by 1 decibel when the input is at 10 dBm. Then we calculate P1 dB as 21.7 dBm. The P3 measurement setup is here. We create 1500 MHz and 1501 MHz signals. Then we combine it with a power combiner and then amplify it with our amplifier. The output is observed by a spectrum analyzer. The fundamental signals are at minus 6.33 dBm and the third harmonics are at minus 72 dBm here. Then we measure our P3 as 26.5 dBm. As you can see, this is over P1 dB and we cannot reach this power level. The noise figure measurement setup is here. We firstly put the noise source alone on this device. Then we wait for it to warm up for 1 hour. Then we calibrate the device. After calibration, we put the amplifier after the noise source and the device measures our noise figure as 6.87 decibels. These are all the measurements. Thank you for watching.